Today we're going to be reviewing a few vocabulary points for our introduction to speed and velocity, and then we're going to be talking about the equation to find average velocity and doing a couple of example problems. So let's review some vocabulary first. So reference points. So we need a reference point when making measurements related to motion. And so a reference point is a place or an object used for comparison to determine if something is in motion. So the motion is relative to this reference point, whether it's ahead or behind or in front. It is in reference to this point. So generally, reference points are objects that are fixed relative to the earth, such as a building, a tree, maybe a sign, etc. Sometimes people are reference points also, as long as we stay in a fixed position. Okay. So then what is a position? So a position is where an object is at any particular time. So position can change, but it's in that moment, where is that object? And that is a position. Distance and displacement seems very similar, but they actually have slightly different meanings. Distance is the length of the path between two places. And distance is dependent upon that path. So if we look at this picture, this bicyclist, oh my gosh, that's hard to say. This person riding a bike is traveling on this path. The distance is how long they actually took from here to here traveling on this path. That is our distance. Our displacement, however, is the direction and the length of the vector from the starting to the ending points. So displacement is not dependent on path, and it is only dependent on the starting and ending positions. Okay, or points. So this is like your most direct point from A to B. So yes, the person riding the bike started here, they went all of this distance, but their displacement is only from their starting to their ending position. So then motion. So let's actually get into the definition here of motion. So motion is an object's change in position relative to a reference point. So the direction of an object's motion can be described with a reference direction, such as north, south, east, west, up, down. Also degrees, so 90 degrees, 180 degrees, 270 degrees, whatever that is. So when we're talking about motion, specifically velocity, we have a change in a position relative to a reference point in a specific direction. So looking at this cute little picture, if person C is your reference point, then you have person A running 4 meters per second to the right and person B running 3 meters per second to the left. So your reference point here would be C with a change in position in a specific direction. So speed then is the distance traveled by an object divided by the time that it takes to travel that distance. So it is a rate. So it is a specific distance per unit time. So common units in physics are meters per second, kilometers per hour, you can have kilometers per minute, any combination of a unit of distance over a unit of time. So how is that different from velocity then? So velocity is the speed, meaning we still have a distance or displacement over time of an object, but it's in a particular direction. We'll talk more about vector quantities later, but for now we're just looking at speed being distance per time and velocity being speed in a particular direction. So velocity must include a reference direction. And again, that could be your, cardinal directions, north, south, east, west, up, down, left, right, or it could also be degrees, any of those things. And an object's velocity is only constant if its speed and direction don't change. So if its direction changes and makes a turn left, then you don't have a constant velocity anymore. Okay, let's go ahead and look at how do we actually solve for this then. So our average velocity is our total displacement over our total time. So let's just dive in. So during a 5-kilometer race, a participant finishes 35 minutes in 35 minutes traveling along the track in an eastward direction. What is their average velocity? So I'm given the 5 kilometers, so I'm going to underline it. Above it, I'm going to write delta x because that is my displacement. If they finish in 35 minutes, which is my total time, so above it, I'm going to write delta t. And I'm looking for the average velocity, so I'm going to circle. So my velocity equals my displacement and my time. So I'm just going to fill it in. My velocity, I don't know. My distance is 5 kilometers and my time is 35 minutes. So if my average velocity is my change in position over my change in time, I'm just going to plug this in. So 5 kilometers divided by 35 minutes. Okay. So in the calculator, 5 divided by 35, 0.14. So 0.14 kilometers per minute. So whatever you do with the numbers, you do with the units. So 5 divided by 35 gives me 0.14. But the kilometers divided by minutes is kilometers per minute. So whatever I did with my numbers, I'm going to do with my units. In this case, I'm not concerned with significant figures. I'm just interested in finding that answer. Now that might be my speed, but it's asking for velocity, which means I need a direction. So I look back at my question and it says eastward. So I'm going to also say east. So 0.14 kilometers per minute east. That is my answer. Okay, let's do another one. How long would an airplane take to travel westward from New York to San Francisco if it must travel 4,129 kilometers at an average velocity of 650 kilometers per hour? Okay, so I'm looking for time, so that's how long. So I'm going to circle it. I know I'm traveling westward, so that gives me a direction. I have 4,129 kilometers, so above it I'm going to write delta x because that's my change in position, and a velocity of 650 kilometers per hour. So this is my average velocity. So v equals delta x and delta t. Let's fill them all in. This just helps keep track of all of your variables for this equation. So 650 kilometers per hour. My change in position is 4,129 kilometers, and my delta t is what I'm looking for. Okay, so there's a few ways that you can do this. You can rearrange the equation and then plug it in. You can plug it in and then solve. I'm going to rearrange the equation in the way that I always tell students to rearrange it because it will consistently get you the correct answer. So it might take a couple more steps, but you know you're going to set it up correctly. So my average velocity is my change in position over my change in time. I'm going to end up solving for this, but I'm going to rearrange it so that I get delta t equals something. So multiply both sides by delta t because it's a fraction and I want to get rid of that. All right. So delta t times my average velocity is going to be equal to my change in position. Well, now if I'm solving for delta t, I can divide out my average velocity so that delta t, or my time, is going to equal my change in position over my average velocity. And now that I rearranged it, I can just plug it in and solve all in one step, and I know that I'm going to get the correct answer. The big thing here are the units, making sure that your units are correct and in the correct spot so that they cancel correctly, so that way your answer has both the right number and the right unit. So here we go. So delta t, so my time is going to be my change in position, 4,129 kilometers, divided by my average velocity, 650 kilometers per hour. So real quick before we put it in a calculator, take note of your units. Kilometers divided by kilometers will cancel the same way x over x or delta t over delta t cancel. And what you're left with is 1 over hours. When we divide that, the hours comes to the top, and then that's going to give you your unit for delta t. So 4,129 divided by 650 is 6 point. I'm just going to use 2 decimal places. Again, we're not concerned with significant figures. We're just trying to find the answer. So 6.35. And my units now are hours. Okay, so it takes 6.35 hours for that plane to travel in the sky. So this is just some review of some vocabulary for the introduction to speed and velocity with a few sample problems worked out.